This is an actual example of how to identify the limiting reactant. The question reads, carbon reacts with steam, which steam is just H2O gas, at high temperatures to produce hydrogen, H2, and carbon monoxide, CO. Before we do anything, we need to start off with a balanced chemical equation. So here is that balanced chemical equation. And it is already balanced even though no additional balancing had to be done. So imagine that you're mixing 2.4 moles of carbon and it's being exposed to 3.1 moles of steam. We want to identify the limiting reactant. Is it carbon or is it water? We start the problem by picking one of these values that represent the amount of reactants. It doesn't matter which one you pick. I just picked the first one for no particular reason, and then you complete a mole-to-mole ratio using your balanced equation. For every 1 mole of carbon, there is 1 mole of water. We make sure our units cancel out diagonally, and if we had 2.4 moles of carbon available, we would need 2.4 moles of water. That's how much is needed if we started off with 2.4 moles of carbon. So what we're going to do is we're going to compare the amount of water we need, steam we need, to the amount of steam that is available. According to the problem, there's 3.1 moles of steam available. So as we compare how much we need versus how much is available, I can see there is more than enough available, which means steam, water in its gaseous form, is the excess reactant and carbon is the limiting reactant. The problem is actually not over because the next step asks how many moles of hydrogen gas is formed. Well, in order to find the amount of product that's produced, we're going to do a GWR problem. We're going to set up the GWR where the given is the amount available limiting reactant. So because in the previous slide we identified carbon as the limiting reactant, we're going to start off with that 2.4 moles of carbon, that's how much is available of the limiting reactant, as our given. The want is moles of hydrogen gas, because the problem says so, how many moles of hydrogen gas is formed, and do make sure that hydrogen is a diatomic, it's H2. Some people think that carbon is a Brinkelhoff element because you do hear that Kohlhoff, but the C sound in Brinkelhoff is actually chlorine, Cl, so carbon is not a diatomic. Now for the relationships. I see carbon, I see hydrogen, so let's focus on a mole-to-mole ratio between carbon and hydrogen, which is really just 1 to 1. I don't see grams anywhere, so we don't need any molar masses, and we can just proceed with the problem. There's really not much to calculate here because your answer comes out to be the exact same numerical value. 1 and 1 cancel each other out, and we end up with producing 2.4 moles of hydrogen gas. I want to tell you that in reality, in a real lab setting, we probably wouldn't be talking in terms of moles. So in real life, the problems will be more in terms of grams, but for the sake of simplicity for this high school chemistry class, I tried to keep it simple by only showing you problems that involve moles.